What happens when even 5G can't keep up? That's not just a hypothetical question, it's the starting point for the next chapter in wireless communication. 6G. While the world is still embracing the power of 5G, the gears of innovation are already grinding toward a future where your devices don't just connect, they predict, adapt, and transform your reality. Welcome to nerdsection.com. Let's rewind just a bit. Each generation of wireless tech has pushed the boundaries of what's possible. 1G gave us analog voice, 2G brought text messaging, 3G turned phones into basic internet devices, 4G made mobile streaming and social media truly ubiquitous, and 5G, it opened the floodgates to ultra-fast mobile broadband, low latency gaming, and the first generation of large-scale Internet of Things ecosystems. But even as 5G is still rolling out globally, its limitations are already becoming clear. Data demands are exploding, spurred by technologies like augmented reality, AI assistants, autonomous vehicles, and the digitalization of entire industries. Enter 6G, the sixth generation mobile network standard that promises to meet these demands not just with more speed, but with fundamentally smarter, more adaptive, and far-reaching capabilities. The vision for 6G is ambitious. We are talking peak data rates of 1 terabit per second, sub-millisecond latency, and ultra-reliable low-latency communication. That makes real-time feel like an understatement. How? One word, terahertz. 6G will push into the sub-terahertz and terahertz frequency ranges, particularly between 100 GHz and 10 terahertz. These frequencies are capable of carrying massive amounts of data, but come with challenges like signal attenuation and shorter range. That's why we'll likely see a hybrid of ultra-dense small cell deployments, beamforming antennas, and intelligent reconfigurable surfaces to maintain stable connections. But let's be clear, 6G isn't just a faster 5G. It's a reinvention of the network itself. AI and machine learning won't just be running on the devices connected to the network. They'll be integrated into the network infrastructure. We're heading toward what's being called a cognitive network, one that learns user behaviors, predicts congestion, automates management, and adapts on the fly. Another defining feature will be the integration of sensing and communication. 6G networks could act like a distributed sensor, using radio signals to monitor environments, detect motion, track objects, and even support health diagnostics by analyzing changes in body vitals. Picture a world where your smart home knows you're stressed by your breathing patterns, or where autonomous vehicles communicate with each other and their surroundings, not just via data packets, but by sensing and mapping the entire urban environment in real time. And then there's the Internet of Everything, not just devices, but people, processes, data, and even digital twins, simulated versions of real-world objects and systems. 6G is expected to support simultaneous device densities of over 10 million devices per square kilometer. That means we're talking about mass connectivity on a scale never before imagined. Smart clothing, ingestible medical sensors, connected farms, entire cities communicating in symphony. 6G also aims to unify the physical, digital, and biological worlds. Think holographic telepresence, live 3D representations of people you can talk to and interact with as if they were right in front of you, or full-body haptic feedback suits that let you feel virtual environments. These aren't just upgrades to video conferencing or VR gaming, they're entirely new modalities for human connection and experience. On the international stage, the race for 6G leadership is already underway. South Korea, China, the US, and Europe have launched major research initiatives. The HexaX and HexaX2 projects in the EU are laying foundational frameworks. The US has the Next G Alliance, and China is investing in 6G trials through national telecom operators. The goal? Establish global standards and be first to market. And with patents, spectrum policies, and manufacturing capacity all in play, this race is about more than technology. It's about geopolitical power. Now, all of this potential doesn't come without hurdles. Power consumption is a huge concern. With more devices, denser networks, and higher frequencies, Energy efficiency has to be radically improved. Security is another mountain to climb, with 6G networks possibly embedded into healthcare, finance, transportation and defense. Resilience to cyber attacks will be critical. Quantum-safe cryptography, AI-based intrusion detection, and decentralized authentication methods may all become standard components. Standardization will also take years. The ITU has already started defining the IMT 2030 framework, laying the groundwork for what 6G systems should deliver. But the technology roadmap is still being written. Most experts predict early deployments around 2030, with test networks and prototypes arriving as early as 2028. And here's the twist. We may not even need a phone in the traditional sense by the time 6G is mainstream. With edge computing, smart wearables, brain-machine interfaces, and seamless mixed reality environments, the terminal could become invisible. Just another part of the ambient computing fabric that surrounds you. So yes, 5G feels fast now, but in a decade, it may seem like dial-up compared to what's coming. 6G is not just the next network. It's a foundational pillar for the next digital civilization. And we're all going to be living in it. The terabit future is on the horizon. Thank you so much for watching. Don't forget to like and subscribe. And check out our video about the DeepSeek AI. See you next time.